Welcome to classes on organic chemistry. Today's class is General Organic Chemistry, Higher Secondary first year. This class is equally important for the student of Higher Secondary second year, those who are the aspirant of entrance exam. This class is important only because of the fact that it is the base of organic chemistry. It is the background of organic chemistry. It is the treasure of organic chemistry. It is the backbone of organic chemistry. It is the essence of organic chemistry. If you do not have idea on this general organic chemistry, whole organic chemistry in future in class second year will be a tough for you. So to get rid of the fear of organic chemistry, you must have mastery over this chapter. And this chapter seems to be a very tough one for the student because of the fact that this chapter is not chronologically arranged in any of the textbooks or any of the books. So I have arranged in such a manner that without skipping, if you please continue watching my classes from 1 or 2 or 3, 4 classes will be there in organic chemistry. I hope, I assure, I challenge that organic chemistry always will be and very interesting for you. So at the very beginning, I will start hybridization. Hybridization, you will get it in inorganic chapter also. So in very short, I will define it. It is intermixing of the process of intermixing of orbitals to give equivalent sets of orbitals called hybridization. Very simple. In a very simple and precise manner I have defined. You will get lots of detail, a lot of things will be included in the definition in the later stage when we will discuss in organic chemistry the hybridization structure. It is a very important fact. The process of intermixing of atomic orbital to give equivalent sets of orbitals is called hybridization. Simple. Because to define hybridization, our main motto is to come on covalent bond, because organic chemistry is mostly consists of covalent bond and all the problems arising out of covalent bond. So what is modern concept of covalent bond? Modern concept of covalent bond, when there is overlapping of one atomic orbital with the atomic orbital of another atom. One atom. It is nothing but overlapping of one atomic orbital of one atom with the atomic orbital of another atom. It is called covalent bond. It is modern concept. So covalent bond is due to overlapping. So we will try what are the possibilities of overlapping. I am chiefly concerned with the concept of your textbook with a bit elaborate, and I have systematized the structure in a chronological fashion so that you will not get any problem in understanding the any concept, because a lot of small and smaller points are to be discussed to make the GOC is very important and very easy, because a lots of points are there and chapter is very huge, so it's a very difficult to sum up the structure, the chapters. So concept of covalent bond. So when we are coming with the overlapping, then we'll talk of type of overlapping. types of overlapping. One is head-on overlapping, or end-to-end overlapping. This is the type of the overlapping which occurs between head and head or end to end of two orbital, and this type of overlapping takes place between SS, SP or PP. Say S orbital is spherical, P orbital is dumbbell in shape. So this is called overlapping, S and P. Now what is SS? Very simple. S is spherical, another S is spherical. This is SS overlapping. What is PP overlapping? This is P and this is also P. So that is PP overlapping. So SS, SP, PP type of overlapping will give rise to sigma bond. So now what is sigma bond? A sigma bond is a bond which arises out of the overlapping of SS, SP, PP atomic orbital. Am I right? This is sigma bond. Now, what is second type of overlapping? Type 1. What is second type of overlapping? Second type of overlapping is lateral overlapping, or sidewise overlapping, or now what is this type of overlapping of atomic orbital where occurs only in case of PP, where overlapping occurs sidewise. This type of overlapping is called lateral overlapping or sidewise overlapping, and due to this type of overlapping, bond form is called pi bond. Simple, sigma and pi. One is head-on overlapping, other is side-on overlapping. We are defining covalent bond in terms of hybridization and overlapping. Now, is sigma, other is pi. Now, what is sigma? Arising out of end-to-end overlapping, and this is due to sidewise overlapping. Number 2, electron density is cylindrical around bond, and electron density is maximum in the cross-sectional plane of the orbit. There in sigma bond, free rotation is possible. No free rotation is possible. Energetically, this bond has high energy and it has got low energy. Number 5, two atom has only one sigma bond, but two atom may have one or two pi bond. Next, in between two carbon only one sigma bond is possible, but in case of pi bond there may be one pi bond or two pi bond is possible. Number 6, independent existence of sigma bond is possible. Existence of sigma bond. Pi bond exists along with sigma bond. That is, without sigma bond is first. Without sigma bond, pi bond is not possible. That is, without pi bond, sigma bond is possible. So sigma bond is existence is independent of anything, but existence of pi bond is dependent upon the existence of sigma bond. If no sigma bond is there, no pi is there. It is dependent. Am I right? So next one is very important. A lots of questions are often asked from sigma and pi bond. Next one is greater extent of overlapping occurs in sigma bond, hence it is stronger, and smaller extent of overlapping is possible in pi bond, hence it is weaker. Next one is sigma bond is directional, hence structure of the molecule depends upon the shape. Structure of the molecule depends upon sigma bond, and pi bond is non-directional. Hence its structure of molecule does not depend upon the pi bond. It is directional. That's why sigma bond, the structure of a molecule depends on sigma bond. This is all about some of the differences between sigma and pi bond. Next type of hybridization is sp3, sp2 and sp. Here 1s, not 1s, twice p, one. For the sake of time I am writing 1s. It is 1s, 1s and 3, three, 3p, 1s, 2p, 1s, 1p. Number of orbital involved in hybridization of sp3 is 1s, 3p, one, three. In this way. Now second point is that unused p orbital in sp3 nil. No unused p orbital is there. There is one unused p orbital, there is two unused p orbital. Number 3, there are 4 sigma bond, number of sigma bond, 4 sigma bond, and here 1 sigma, 2 pi, and here 1 sigma 1 sigma 1 pi 1 sigma 2 pi. Next, the percentage of S character. There is 1 and 1 3, 3 and 1 4. 100 divided by 4 is equal to 25. Our 4 part is 25 is S. S character is 25. S character is 25. Here 2 and 1 3. 3 divided by 100 equal to 33.3. So 1 S means 33.3. Here 1 part and 1 part 2 part. 100 divided by 2 equal to 50. So S 50 and P 50. So this is some of the fact regarding sp3, sp2 and sp hybridization in term. Another is shape. This is tetrahedral. This is trigonal bipyramidal. Sorry, planar. Trigonal, and this is linear. Bond angle 109, 5, 120, 180. This is some of the fact I have summarized regarding sp3, sp2 and sp hybridization in a nutshell. I have shown you. So now we will show you the trick how to find the hybridization. Where to find out hybridization is a very important thing, and very often questions are asked. So say this now very often I have told you that hybridization, we can just find out the hybridization simply counting the bond numbers, bond pairs, or you can assume its hand. How many hands are there? 1 2 3 4. There is 4. So S is always 1. To get 4 we need 3. So here that carbon, this is 1 hand, 2 3. That carbon has 3. So to get 3, this is fixed 1, we need this. We need this sp2. So for that carbocation, this is 1 hand and this is 1 hand. Let me take one free radical, say this. For that carbon, this is 1 hand, 3 bonds 1 hand, and this is 1 hand 2. It is 2 sp. So this is the simple way to find out the hybridization. But one of the fact I am telling you, to calculate the hybridization, we need, say, lone pair. We'll assume it 1 hand if there is lone pair. If there is 2 lone pair, 2 hand. If there is negative sign, it is 1 hand. If there is dot, we will not assume this in counting. Am I right? So, and if there is double bond and triple bond will be 1 hand and triple bond as a whole will be 1 hand. This is the concept to find out the hybridization. But the lone pair is a very essential fact. You should know this, because if I say what is the hybridization of this one in inorganic chemistry, I will explain. And this is methane. I have told you, in case of methane it is sp3, because carbon has 4 hand or 4 bond, sp3 1 and 3 4, and if you say simply like this sfff4 it is sp3, you will be wrong. So lone pair calculation for Lewis-Dot structure, to draw Lewis-Dot structure, to get formal charge, to get hybridization in second, there are lots of questions will lone pair on xcf2 xcf6 you are asked to get the hybridization, tell the hybridization. So it is a bit tough to find out lone pair. So one of the process is, it is what is group number plus the valence electron of this one. So this is 7, valence electron is 2 7, am I right? So valence electron 7, 7 4 ja 28, group number plus 28 divided by 8. What is group number? Group number is, its group number is 16, group means 6, 6 plus 28 means 34, 38, 4 divided by 8, 8 is equal to 4, and remainder 2, 2 means 1 lone pair, 2 is the electron, means 1 lone pair. So it is bond pair. So if you add up the group number and the valence electron, 4 times of that one divided by 8, you will get the result. This result will be your bond pair, and the remaining number of electron is the electron pair, electrons, number of electrons. That number of 2 electrons equal to 1 pair. So there is 1 lone pair. If there is any negative sign, you please add it. If there is negative sign, add it too. Am I right? And if there is hydrogen, mind that for that hydrogen you always assume it's 7. Please keep it in your mind. Always hydrogen you assume it H7, because you see here carbon, if you want to find out the electronic configuration, carbon is what? It is 6, 4. Its group number is 4. Group number is 4. 1, 2, 3, 4. It is 7. 7 4 ja 32. 32 divided by 8, you are getting, sorry, 28. 28 divided by 32 is equal to 4. It has got 4 bond pair, no lone pair, hence it is having no lone pair. But here when we have calculated group number plus valence electron divided by 8 will be bond pair, plus remainder is equal to number of electrons divided by 2 is equal to lone pair. So it has got 1 lone pair. Am I right? To draw the Lewis-Dot structure, you should know the lone pair, and lone pair has a much effect upon the structure of the molecule if you can't find out structure and hybridization. So there is 4 hand and 1 lone pair will give you, we have calculated lone pair 1 hand, so 5 hand. So to get 5 hand, that is 3 and 1 4, so 1 D is there. So 1 2 and 3 5, sp3d, its hybridization is 3, its structure is not tetrahedral. Mind that I have shown you a simple trick, please keep it in your mind. So I have explained determination of hybridization. Now what is application of hybridization? What application of hybridization? How hybridization is helpful? First of all, to size of orbitals, hybrid orbital. Say one is sp3, other is sp2, other is sp. How will you find out which hybrid orbital is bigger and which one is smaller? So I will tell this. So how? Because here s electron is 33, sorry, percentage of s is equal to 25, percentage of x equal to 33, and it is 50. So less the percentage of s character, bigger is the size. More the character of, so this is the reason why, because s orbital is spherical. So whenever it overlaps during hybridization process, so it goes penetrate much closer to the nucleus of other atom. That's why if the percentage of s character is less, the size of more if percent more the s character, more is the closer to the internuclear distance of other overlapping atom, smaller will be the size. So less the s character, more will be its size. Am I right? Now it is size of orbital, hybrid orbital, size of hybrid orbital. Now if you tell size electronegativity, this is very important. Hybridization is a very important concept. You can find out a lot of things. Electronegativity of orbital. Now electronegativity is again related to the size. Smaller the size, higher is the electronegativity. Smaller the size, higher is the electronegativity. This is the smaller in size, higher is the electronegativity. Am I right? So third one, electronegativity of hybrid and unhybrid orbital. To find out electronegativity of hybrid and unhybrid orbital, this is sp, sp2, sp3. So all are hybrid, am I right? And one is unhybrid and other is unhybrid. If you mixed up this one and if you were asked to arrange in increasing or decreasing order of electronegativity, so answer will be like this. These three are hybrid and unhybrid. So this is 100% of unhybrid, 100% S. It is the smaller. It is 50%. It is 33%. It is 25%. It is 25. It is 33. It is 50. It is 100, and it is 100 of P means S is 0. S is nothing, no S is there, S is 0. So S character is decreasing. S character is decreasing. So highest the S character, smallest is the orbit, hybrid orbit or unhybrid orbit. So highest percentage of S is the smallest one, second, third, fourth, fifth. So as the S character decreases, the size increases. S character becomes 0, P is the highest. Am I right? So now acidity, how will we define acidity of hydrocarbons, or you can calculate water, ammonia and acetylene. So here very interesting thing, inorganic and organic I have mixed up to make you understand what's happened here. We will just consider the electronegativity of central atom or the atom attached to the other one. So here oxygen, nitrogen, carbon. Oxygen is more electronegative. More the electronegativity of the central atom, more is the acidity. So order of acidity is this, electronegativity. Am I right? Now the central or around which other atoms are attached, we have calculated or assumed or find out the acidity with the help of electronegativity. Now if you are asked to arrange in increasing acidic order of these three, say how will you? It will be a bit tough, but I think you can, because one of the fact I have not mentioned here, that carbon-carbon bond length, carbon-carbon single bond length equal to 154 Armstrong, carbon-carbon double bond length equal to 134 Armstrong, carbon-carbon triple bond equal to 1.20 Armstrong. So more the S character, it is sp, it is sp2, it is sp3. Less the S character, more is the bond length. So as S character increases, bond length decreases. So here it is S, it is sp3, it is sp2, it is sp. If you speak about hybridization, we get in this way. So we see more the S character. S is 25, S is 33.3, S is 50. More the S character, more is the acidity. So acetylene is the highly acidic in comparison to ethene and ethane, but it is very weak acid. It reacts with a very strong base to extract that hydrogen, otherwise it will not react. But if you compare acidity, it is more. In other way, we can tell that carbon carbon triple bond unit and carbon carbon double bond unit and carbon carbon single bond unit, in terms of bond length, this unit has got the least bond length. Least bond length means it is compact in comparison to this in terms of bond length. So smaller the unit, greater is the electron. What is electronegativity? It is the tendency to attract the shared electron pair towards itself. Smaller the size of an atom, or higher is the electronegativity. The smaller the unit of this part, smaller is the tendency to attract the shared electron pair between carbon and hydrogen towards itself, so that hydrogen will be released easily as proton. So ethyne is stronger acid than ethene and ethane, though acidity is nil at almost. Am I right? So this is knowledge on dipole. What is dipole? Dipole means it arises from polarity due to due to due to difference in electronegativity. The polarity arises between two adjacent atom of a molecule. Degree of polarity is called dipole, and the dipole moment is designated by d, and its SI is d by and it is designated by d. What is exactly dipole moment? Due to difference in electronegativity, the polarity arises between two adjacent atoms of a molecule. The degree of polarity is called the dipole. If the polarity is more dipole moment. If polarity is less dipole moment. Say carbon and carbon, it is attached to something halogen group chlorine. So electronegativity of chlorine is more than carbon. Due to electronegativity difference, it will attack the bond pair towards itself. It will gain partial negative charge and partial positive charge. This is called polarity. Am I right? And the degree of polarity is called dipole. This is polar, and this degree of polarity is called dipole moment. Now let us see how you will measure the dipole. Dipole moment, to measure dipole moment, does not directly depend upon the polarity. It doesn't not only depend upon not only depend on polarity. Means more the polarity, more is the dipole, means more is the electron difference, more is the polarity, more is the dipole. One is polarity. It also depends on structure of molecule. Now what does structure of molecule means? Before that I am telling, symmetric molecule has zero dipole. Now let us define what is symmetry. Now you may not have the true knowledge on symmetry. What is symmetry? Number one, recognition of symmetry is that central atom is bonded by same atom. If in a molecule central atom is bonded by same atom, say CH4, say BF3, say CS2, say CH double bond CH2, say CH triple bond CH. You see here this central atom CCl4. CCl4. Am I right? CCl4. Carbon is bonded with the same type of hydrogen, hydrogen, hydrogen. B central atom is bonded by fluorine, 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 bonded by SSS, bonded by hydrogen, 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 bonded by hydrogen, 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 bonded by chlorine, 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 4 chlorine. So if the central atom is bounded by the same type of atom, these elements, these compounds are called symmetric compound. Now, what is the other source to know the symmetry? Symmetric compound. Symmetric compound means having no lone pair. So lone pair is a very important thing to know. You should calculate. The method I already have shown you. Am I right? So if the molecule does not have any lone pair, so if you calculate, you will get no lone pair here on carbon. If you calculate, you will find no lone pair in this. If you calculate, you will find no lone pair on boron. Am I right? So the compounds, the central atom of this compound which has no lone pair is again symmetric. But if you assume it SF4, then you please find out whether there is lone pair or not. If there is no lone pair, then it is symmetric. If there is no lone pair, it is unsymmetric. Now water, it is unsymmetric because lone pairs are there. Am I right? Ammonia, NH3 and dot, NH3, it is not symmetric because lone pair. So lone pair is one criteria. Another is the atom which is attached to the central atom. If all are same, it is symmetric. If there is no lone pair, it is symmetric. So all the symmetric compound does not have any dipole moment. CHF3, CH3, CH3, CHI3. If I ask you to find out the increasing or decreasing order of dipole moment, so you see fluorine, chlorine, bromine, iodine, they are in the 17th group, 17th group. So one above the other. So if you move from top to bottom, electronegativity decreases. Lesser the electronegative, lesser is the extent of the polarity, lesser is the bond. So the order of polarity is this. Am I right? Now if you assume CH3, CH2, Cl2, CH, Cl3, CCl4, if all are chlorine, 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 same atom, and if you are asked find the polarity order will be like this, because of lastly you are getting symmetric one. Am I right? This is 1.86, this is 1.63, this is 1.03, and this is 0. Steric effect minutely follow. This is a very important concept, and many of you do not have the knowledge on steric effect. I am just writing the definition very speedily. Due to the presence of bulkier group around the reaction center, the occurs mechanical, there occurs interference. As such, the attacking reagent finds difficult to approach the attacking center and thus causes the variation on chemical reactivity. This effect is called steric hindrance or steric effect. Very minutely follow, because very often you will get this term, and this term has a tremendous influence on the reactivity SN1 and SN2 mechanism, E1 and E2 mechanism. In each and every mechanism you will get this steric effect. So from the beginning you please come very familiar, be very familiar with this effect due to the presence of bulkier group around. Just I am drawing this and you can understand very easily. With this I will explain. Say this is tertiary alkyl halide, 3-degree alkyl halide, where carbon attached with the chlorine does not have any hydrogen, is called 3-degree alkyl halide. It is tertiary alkyl halide. Now you see, due to the presence of bulkier group, these groups are bulkier groups. Due to presence of the bulkier group around the reaction center, that is the reaction center where the attacking reagent will attack here, reaction center, there occurs mechanical interference. There is a disturbance. For what? For approaching the attacking reagent. The attacking reagent, nucleophile, electrophile, that tries to attack through that carbon. They find difficult to come towards this one due to bulkiness of this. And due to this fact, the SN1 and SN2 mechanism you will get later in details will be greatly affected. This phenomenon of bulkiness of the group of atoms or groups attached with the reacting center is called steric hindrance. Now what is this effect? Actually you see, very interesting way you follow. This is very important because nowhere you will get the proper explanation. Please come to, let us now explain what's happened. You see, it is tremendously strained. This compound is tremendously strained, strained, under pressure, strain, huge energy is there. To get released, we get upon hydrolysis, this chlorine get released. Due to the bulkiness of this group, it is highly strained. To release this strain, the chlorine detach away, give rise to carbocation, 3-degree carbocation. You will get later on, a bit later on. To get 3-degree carbocation, to get release of the strain due to the bulkiness of this, we are getting carbocation. Because a bit later you will get SN1, SN2. In one reaction there is carbocation form, in another reaction there is no carbocation form. So one thing will just travel in your mind, that in which form we will get carbocation, in which form we will not get carbocation. Very often in the books it is written, if there is 3-degree alkyl halide, there is the possibility of getting carbocation, but no reason is there. The reason is there, 3-degree carbocation is stable due to the plus I effect. We will come in later on. But most important reason is that when this is bulky and bulkiness is there, due to this it is highly strained, and to release this strain we very easily get. But important fact you see, CH3, CH2, say this. If I ask, if you hydrolyze it, will you get this? Will you get this? Never. You will not get this thing, carbocation. You will not get carbocation on hydrolysis, because there will be reaction will proceed, but this will be SN1. Transition state will coming later on, a bit later on. Transition stage will appear without forming any carbocation, because it will not form carbocation because it is not highly strained. No bulky groups are there. And another, in terms of stability of carbocation we can explain, but since we are dealing with the steric effect, hence we will say it is not highly strained. So release of chlorine is not necessitated with stability of this carbocation. So release of carbocation is not possible in this type of alkyl halide of 1 degree type of CH2Cl is 1 degree type of alkyl halide. But one confusion very often comes in the organic reaction. Please try to clear up the confusion exactly now, so that you will enjoy the chemistry while you will learn. See, sometimes you will find, I have shown you that if the alkyl halide is 3 degree alkyl halide, 3 degree alkyl halide, there is ample chances of 3 degree carbocation, 3 degree carbocation. Otherwise, we do not get carbocation. In 2 degree and 1 degree alkyl halide, we do not get carbocation, because that mechanism proceeds to transition state mechanism. But now you see, let me draw another figure of CCH3, here CH2Cl. Now, if I ask you whether carbocation of this type is possible, because if you release this chlorine, you will get CH3, CH2 plus, it is carbocation, again CH2, it is carbocation, is one type carbocation. It contradicts to my previous concept. I told you, if 3 degree alkyl halide is there, it is 1 degree alkyl halide, there is possibility of 3 degree carbocation, because highly strained molecule get released strain by leaving out the chlorine to get the carbocation of 3 degree type. But if you get carbocation of this type, it is not 3 degree, it is 1 degree carbocation. Am I right? CH2 hydrogen, 2 hydrogen is there 1 degree, 1 hydrogen is there 2 degree, no hydrogen is there 3 degree. So 3 degree is possible in 3 degree alkyl halide. But here I am asking you whether will you get 1 degree carbocation of this type in this reaction, because will you get this carbocation? My answer will be here 1. My answer will be here yes. Now you will be confused. Earlier you have told 3 degree carbocation, 3 degree carbocation. But in case of 1 degree, it is not possible, because there is no steric hindrance, no strained compound is there. But here, this is beta carbon and this is alpha carbon. So alpha carbon is highly strained due to presence of bulky third butyl part. So this bulkiness of beta carbon will make it highly strained. That's why the release of chlorine gives rise to this one. So mind that 1 degree carbocation is possible only when there is highly strained. So sometimes in the reaction mechanism you will find that despite there is no 3 degree alkyl halide, 1 degree alkyl halide possible carbocation, 1 degree carbocation is possible, which is in terms of the rule is not possible to form, but yet they have shown the mechanism SN1. Carbocation forms means SN1. It should have been SN2, but it is SN1. Because of bulkiness, there will be SN1 reaction, there will be carbocation. And another reason is that you will get later on, there is shifting of carbocation in later stage. Sorry, alkyl halide, methyl group. Shifting of methyl groups gives you 3 degree. It is later part, but this is possible, I am saying. Now, another point is second year you will get that, say benzyl chloride, say CH2Cl, and say this is Cl. Am I right? So this is Cl. Whether the mechanism is SN1 or mechanism is SN2, I am here showing you, telling you this is SN1 mechanism, because here Cl is, if released, the carbocation is 1 degree carbocation. If Cl is here released, carbocation is 2 degree carbocation. Both the carbocation has formed out of some circumstances of bulkiness or the resonance. Both of these two reactions will follow by forming 1 degree and 2 degree carbocation, and it will follow SN1 mechanism. Though in the book, in maximum books, it is told that if alkyl halide is 3 degree, it is not 3 degree, it is 1 degree. It is halide, it is 2 degree. Alkyl halide is 3 degree carbocation is possible. But here we have seen 1 degree carbocation, 2 degree carbocation, here 1 degree carbocation. It is possible only when there is static hindrance, or only when there is possibility of resonance, that is positive charge is well distributed between the two benzene group, and positive charge is well distributed in between this benzene ring, giving stabilization of this one. So if there is any factor of stabilization of carbocation, then there may be 1 degree or 2 degree carbocation formation. So this is very important thing which I have explain, and hope this will come in need in future class, higher secondary class, or in any entrance exam type of the. Now the heart of organic chemistry. I am explaining the heart. Without heart, a human being cannot move or run. So without heart, an organic chemistry cannot move, and that is the heart. Just to minutely follow. Electronic displacement in covalent bond. In covalent bond. This is heart. Mind that this is heart. And I assure you, the maximum of you do not have the clear concept of electronic displacement. For the sake of your exam, you know something from just going through the notes of your class teachers or this and that, and minutely follow whatever I will tell today will be a big hand for you in future, and one day you will say that I have mastery over the chemistry as because of this class, because electronic displacement of covalent bond. So what's happened? The attacking reagent, though we have not started yet, attacking reagent, either it is plus or attacking reagent is minus. I am telling you the factual part, that what is electronic displacement and why it is important to know. Am I right? So attacking reagent is generally positive or negative. The elements, the species which attack the substrate is called attacking reagent. Either plus or minus, maybe lone pair of this and that. For time being, I am telling it is plus or minus. So if the attacking reagent is plus and minus, the organic compound consists of carbon-carbon covalent bond needs to be polar, needs to be partial polar. But since it is covalent, so polarity is not there. So to get the attacking reagent, to make the attack of attacking reagent feasible in the organic compound where covalent bond is there, we need some polarity of covalent compound, carbon-carbon bond. We need some polarity in carbon-carbon bond. That polarity may be of permanent, that polarity is due to some effect in organic compound, which are either minutely follow, which are either permanent or temporary. Very famous thing. So we need some polarity in the organic covalent bond. Since attacking reagents are plus and minus, to make the reaction viable or feasible, we need some polarity in covalent bond, and this polarity in compound of organic chemistry is due to some effect on the organic compound. These effects may be permanent or temporary. Now what is permanent? Permanent effect is operating in the molecule permanently, which is called polarization effect. So due to attacking reagent are plus and minus, that needs to be attacked upon the organic compound of covalent bond, which should be polar, and to get this polarity we need some displacement of electron. Either will just move some electron towards other one, displacement of electron. That displacement is called effect. That displacement or effect is either permanent or temporary. If the effect is permanent, it is operating in the molecule permanently, always operating in the molecule, and these permanent effects are called polarization effect. And if the effect what is temporary effect? If the effect is induced in the molecule due to the approach of attacking reagent and the effect nullifies soon as the attacking reagent is withdrawn. Very important and essential facts. You please minutely follow. If the effect, that is displacement electron in the organic compound of covalent bond occurs due to presence of some operating things inside the molecule which is operating permanently in the molecule, that is called polarization effect. And if the effect is induced in the molecule temporarily on the approach of attacking molecule, and when attacking molecule is removed, the effect nullifies, effect removes. That effect is called temporary effect, and it is also called polarizability. That effect, temporary effect, is called polarizability. One is polarization, it is permanent effect, always acting and operating in the molecule itself. And another is under the influence of attacking reagent, displacement of electron occurs. When reagent is removed, displacement again comes to its original position. That is called temporary effect, and this effect is called polarizability effect. Now what we summarize, you see, now what is the basic concept, you see how we summarize. This is the backbone of reaction and reaction mechanism. Mind that you can follow this one. In never, no days, you will find any difficulty in explaining the mechanism. You should not try it over and over again. It will be in your grip. Automatically, you can understand the facts. You need not to learn by heart. So, what we conclude from this? Electronic displacement may be of two types. One is permanent, other is temporary. Permanent effect is called polarization effect, and temporary effect called polarizability. Am I right? Sorry, you may not have distinct classification. Now you see is inductive effect, and this is mesomeric effect or resonance effect. This is hyperconjugation. Now what is temporary? This is inductomeric, and other is electromeric effect. I am summing up the class here. For next class, I will tell the main backbone and heart of the chemistry with utmost vigorous spirit. Hope you have understood the class with utmost vigor and enthusiasm. And please don't forget to share and subscribe the class for others to giving the scope of viewing the conceptual class on general organic chemistry. And please don't try to skip the class one by one within 2 or 4 or 6 class I will sum up the general organic chemistry, and my request, you please don't skip, in a serial way please go on. You will find you a successful one if you can understand this one, because you need not learn anything, just you listen my class and go on solving the organic chemistry blindly without any fault. You will get the marks, you will success in entrance exam or in solve the class. Thanks a lot for watching the class.